In this lesson, we are going to work on graphing linear inequalities and also writing inequalities based on a graph. In a linear inequality, the first thing that you want to do is to graph the line, putting it into slope-intercept form y equals mx plus b first, so that you know the y-intercept and then can find the other lines from the other points from the slope. Next, you need to decide whether you're making, this time since we're on the coordinate plane, the line that you draw solid or dashed. Remember that if you have a greater than or equal to or a less than or equal to symbol, you're going to make the line solid, and you're going to make it dashed if you have a greater or just a less than symbol. Then we're going to decide which side of the line to shade on. If it's less than or equal to, if it's greater or greater than or equal to. We can do this by picking a test point and seeing which side of the line to shade on. It's a great idea to make sure the y is by itself before graphing. Remember putting it into y equals mx plus b. Here's our first example. Y is less than 2x plus 3. So we are in y equals mx plus b, so we know that the y-intercept is at 0, 3, and our slope is at positive 2. So we're going to graph our y-intercept at 0, 3, and find other points by using our slope, up 2 and over 1, up 2 and over 1. Our symbol is a less than symbol, so we are going to make our line dashed, or sometimes people would call it a dotted line. Making sure to put arrows, and then we need to decide where to shade. Since it's less than, we might think that we shade all values that are smaller going to the left. My feeling is the other method would be to pick a test point, because this dotted line or dashed line has divided the coordinate plane into two sections. This section, which is to the upper left, or to the lower right. If you pick a point in the region, that you will determine where to shade. Now, one of the best points to pick would be the origin, 0, 0. So I'm going to pick that point right here, 0, 0. And I'm going to test to see if the point 0, 0 is a solution to the system. To test the point 0, 0, we simply plug both of those values into our inequality. So is 0 less than 2 times 0 plus 3? Is 0 less than 0 plus 3, which is 3? 0 is smaller than 3. So since 0 is smaller than 3, we are going to shade where that point is located, which is 0, 0. All of the points in this side of the coordinate plane will satisfy this inequality and be solutions to the system. So we tested the point 0, 0, which is the origin, and when we plug that in, it works. 0 is smaller than 3. Let's try the next example. Y is equal to 1, or greater than or equal to 1/2 x minus 2. So the first thing I want to find is my y-intercept, which is at 0, negative 2. Then my slope is at 1/2. So I'm going to put that point 0, negative 2 onto the coordinate plane, and then I'm going to use my slope up 1 over 2, up 1 over 2 to find some of my other points. Now I take a look at my symbol. It's greater than or equal to, so I need a solid line. Our next step is to decide where to shade. Are we shading up and to the left or down and to the right? It says y is greater than or equal to. Again, I feel like the best method is to pick a test point and see, should I shade in one of these regions? The origin is the best test to pick because it's the easiest numbers to substitute into the equation, and the only time you wouldn't use the point 0, 0 is if your line passes directly through 0, 0. So let's substitute that in. Is 0 greater than or equal to 1/2 times 0 minus 2? Is 0 greater than or equal to 0 minus 2 is negative 2? Yes, 0 is greater than or equal to negative 2. And since we said yes, that means yes, the point 0, 0 works. And that would tell me that any points in this area would work. All of these points in this area would be solutions to our inequality. In our next example, 2x minus 5y is less than or equal to 10. We don't have the y by itself, so that's our first business, is we have got to get the y by itself. So we're going to subtract 2x from both sides, and we want this written in slope-intercept form, function form, so we're going to put the x's first and then the numbers. Now we're going to divide each piece by negative 5, each of our terms. So we have y, and since we divided by a negative, we need to flip our inequality symbol over. A negative by a negative is a positive, but the fraction 2/5 is reduced, and we will leave it in fraction form because that represents our slope. 10 divided by negative 5 is negative 2. So our y-intercept is at 0, negative 2, and our slope is at 2/5. I'm going to plot the point 0, negative 2, and then use my slope to find other points. So up 2 over 5, up 2 over 5. Then we need to put in our line. Let's take a look at our symbol. Our original symbol less than or equal to, or when we solved it's greater than or equal to. But the equal to does mean that we need to have a solid line. Now that we've put our line on, we need to decide where to shade. Up to the left or down to the right. Again, the best bet would be to pick a test point, and we could pick the point again, the origin 0, 0. That is in the region that's up and to the left. So we'll pick 0, 0. We're going to substitute the 0, 0, and we can substitute it into either the original equation or to the one that we solved. I'm going to do the original equation. So 2 times 0 minus 5 times 0 is less than or equal to 10. 0 minus 0 is 0 less than or equal to 10. Yes, it is. So that means that the origin is a solution to our inequality, and so we need to shade that entire region. That means all of these points in this region would be solutions to this inequality. Here's our next example. We have x being greater than 5. So let's take a look. We know that if we see only an x variable, that this is going to represent a vertical line. And that vertical line is going to take place where the x value is 5. So I'm going to put one of my points at 5, 0. Next, we need to take a look at the symbol, and it's a greater than symbol. So that means that we are going to have a dashed line at x being equal to 5. Next, it says we want all the values that are greater than 5. And since we're talking about a vertical line, all the values to the right of this line for x are going to be bigger than 5. So we'll shade to the right of the line. All of those points would be solutions to this inequality. In our next example, y is less than or equal to -4, we recognize that this should be a horizontal line because the y variable is the only variable that we see. We are going to make our first point at 0, -4, and at that point we need a horizontal line. When we take a look at our inequality, we notice that there is an equal sign. It's less than or equal to, so this is going to be a solid line. We want all the values that are less than or equal to -4. Values that are less than -4 would be below the line. So we will shade below the line, meaning that all points below the line would be solutions to this inequality. To review, we are going to graph the line y equals mx plus b. We're going to decide if the line should be solid or dashed by whether it's greater than equal to, less than equal to, or if it's just greater or less than. We will shade on one side of the line by picking a test point and substituting that into the inequality. If it is a solution to the inequality, we will shade on that side of the line. If it is not a solution, we must shade on the other side of the line. Please complete the reflection.